As we're ready to discuss radian measure, and we'll spend most of our time later on dealing with radians. In calculus, we almost exclusively use radian measure. And radian measure really based on circles. Okay, it's really what it's based on. So as you see here, to define a radian, we need to use a central angle, and a central angle is one whose vertex is at the center of a circle. Okay, so I'm going to actually place my circle, if you will, on a coordinate axis just to make it convenient for us. Okay, so I'm going to draw a y-axis, and I'm going to draw an x-axis. Okay, and so first I'm going to start by putting the center of this circle at the origin. So let me draw a circle, see if I can do this. And you'll have to bear with me, of course, a bit. I'm sure you will. But I'm getting my circle drawn. Okay. Now, let's place our angle, the vertex of our angle is called a central angle. The vertex of our angle at the center of the circle, which is at the origin. So let's say this is the initial side. This is the way we normally do it. This is the initial side of our angle, and this is the terminal side of our angle. Okay. And of course, our angle continues out here. I mean, the ray continues out here, doesn't it, lightly? And of course, it continues along the positive x-axis. Of course, this is the x-axis, this is the y-axis, the way I've drawn it. But that's not so important. It's really the circle that's important here. Okay, so the angle opening we have, let's call this angle theta to have something to refer to. And so this is the angle right here that I'm talking about, theta. Now, let's also further, in this angle that we're dealing with, and the circle that we're dealing with, of course, this is the radius, isn't it? And this is also the radius. Okay, well, I'm prepared to define a radian here in just a moment. Okay, here's the definition of a radian. One radian is the measure of a central angle, I'm calling theta here, that intercepts an arc, S. Okay, so the arc is of length S, equal in length to the radius of the circle. Now, so unfortunately, what I did above is I actually drew the angle first, and that's not really what we're doing when we're talking about a radian measure. So first we have a circle, and then we have the initial side, okay, that I've got there. And what we do then, of course, the idea is this. We take the length of the radius of the circle, okay, which is r, and we measure an arc. We measure that radius in an arc, that is, along the outside of the circle. Okay, so we measure along this outside of the circle. Okay, so arcs we usually give by the name of S, but the length of this arc is the same as the radius of the circle, except it's curved, isn't it? Now, the angle that we get then for this terminal side that this puts us to, once we measure along that circle, that arc amount, it puts us at this position, okay, and the angle that that creates is 1 radian. So in this case, what we see is 1 radian. Is equal to 1, and normally the way we refer to radians is with RAD, okay? So the angle we see there is 1 radian. Well, then the question might be, well, what if we have a different size circle? Is that different? And by the way, I'll tell you this now, just so that you see it later on. A radian is just a little bit less than 57.3 degrees. A little less than 50.6. So we'll say a radian, 1 radian, is approximately 57.3 degrees. Now, we're really not so interested in that, except knowing that that's about what it is. Almost 60 degrees, isn't it? But not quite. Well, and as I was saying, we might have a question, well, what if I used a different angle? Because remember, a different circle. Remember what we said here is the 1 radian depends, it seems like we say, here we take a circle, and we take the radius of that circle, and we measure on the outside of the circle itself, that distance r, whatever that radius is, and where we end up, if we draw that terminal side, then that angle opening is 1 radian. What if we have different size circles? And the answer is it doesn't matter. Let me show that on the next page. So as I was saying, the size of the circle doesn't really matter. Let me draw a circle of radius 1. Okay, well, that's what I'm saying it is, radius 1. Okay, here's the center of the circle. Now, let's make this the initial side No, I'm sorry that that's so ugly. This is the initial side of my angle. And remember, this circle has a radius of 1. So this distance right there is 1. That's the radius. Now let's take that radius of 1 and let's measure right here, okay, that distance. So this is also 1 unit right there. So that means the terminal side of this angle is going to go like this. Okay, this is the terminal side. Now, let's take the same center position, but now let's draw a circle of radius 3. And you'll have to be patient and recognize that I can't draw a perfect circle. Whoops, I got way off there, didn't I? Okay, here's my circle of radius 3. So that means this distance is 3. Now let's take that 3, that distance of 3, that radius, and of course let's measure. Okay, now here's the initial side, and I'm going to measure along the circle starting from this position. And when I measure along the circle starting in this position, of course I come here, and what I'm going to find out when I measure 3 units here, it puts me along that same terminal side. And so, and no matter what, I mean, this angle, no matter which circle I use, it's the same angle, and that angle theta, okay, that angle that I'm referring to there, that theta is 1 radian. So the size of the circle doesn't matter. Okay, the size of the circle doesn't matter. In fact, from here, we can come up with another important piece of information. Well, as we continue with our discussion of radian measure, what I've done here, as you can see, is taken a circle, and I didn't really draw the circle because I didn't want it to mess up what we're seeing here, but I take a circle of radius r and start measuring off radians. So you can see in this first quadrant, out on the outside of my little arrows, like right here, you can see that I'm indicating that if we open up to that position, go r units, then we'll be at 1 radian that I've indicated here. Now, if we start from that position and go r units along the arc, remember that's called the arc, along that arc, we go another distance of r, then we'll be at 2 radians. That's where we are here. And you can see as we move all along what that looks like. So 6 radians puts us a little bit short of a full revolution. And we'll understand that here in just a moment. I mean, we can see it happen there. We can see it. So that's the idea of radian measure. And because the circumference of a circle is calculated by taking 2 pi and multiplying by the radius of the circle, so a central angle of 1 complete full revolution corresponds to an arc of length 2 pi times r, 2 pi r. That is, if we measure the distance, the arc, all around a circle, then we get 2 pi r. Well, that's important in understanding then what the radian measure is. See, what the radian measure is all the way around a circle, 1 full revolution. In other words, what corresponds to 360 degrees in radian measure. So if we have an angle as a central angle in a circle, and we want to know the measurement of that angle in radians, what we do is we measure the arc that creates that angle. So we measure on the outside. That's called, okay, the arc length. We measure that arc, and to know how many radians that is, we needed to find out how many times the radius will go into that length. And so we take that arc length and divide it by the radius of the circle. That is theta measured, this is the angle we're talking about, theta measured in angle, in radians, is the arc length divided by the radius of the circle. The arc length that creates measured by the radius of the circle. So as a picture, okay, where of course theta is radians, in radians. So the picture would be like this. We have a circle, okay, and that circle, let's just say, has a radius of r. So the distance right here, from here to here, is r. Now, we have an angle, let's say, that's over here like this. So our angle theta is there. Now what we do then is we measure this length. We measure this length right here. That's S. We measure that length and we find out how many radiuses there are in that length. So we take that length and divide by the radius of the circle, and that's how many, that's how many radians that angle represents, that in radian measure. So having said that then, if we want to know, what angle we get if we have 1 complete revolution, then that would be theta is equal to the arc length, but the arc length here is the circumference of the circle. And the way we calculate the arc length, the circumference of a circle is 2 pi times the radius of the circle. So what do? We divide the arc length by the radius, and in this case, that would simply simplify to 2 pi, wouldn't it? So that, let me write that here, okay, that is another way to say 1 revolution around a circle corresponds to an angle of 2 pi radians. See, 1 revolution corresponds to an angle of 2 pi radians. That means 360 degrees and 2 pi radians are the same. Well, that pays a lot of dividends, but let's go back up above. Look at the diagram up above, and look where 6 radians is. 6 radians is a little bit short of 1 full revolution. And that shouldn't be too surprising now when we look at it in this slide, because 2 pi radians is 1 complete revolution, okay? 1 revolution, or 360 degrees. Well, pi is about 3.14, isn't it? Approximately, not quite, 3.14. So 3.14 times 2 is about 6.28. So 1 complete revolution is about 6.28 radians, and that's why we see 6 radians is a little bit short of an entire revolution. Okay, that's the idea, to kind of get that in our mind. Well, like I said, these this information about 1 revolution being 360 degrees, being 2 pi radians, that pays a lot of dividends that we'll begin to summarize on the next page. And it will give us a way to convert back and forth from radian measures and degree measure back and forth. Okay, as I said, let's keep in mind that 1 full revolution is 2 pi radians, and so from that we can make some interesting conclusions. What about 1/2 of a revolution? Okay, 1/2 of a revolution. Well, that would certainly be 1/2 of a full revolution. So that would be, a full revolution is 2 pi, and if we're taking 1/2 of that, we divide by 2. So 1/2 of a revolution would just be pi radians. Now, of course, 1/2 of a revolution that we already know about, 1/2 of a revolution, or 1/2 of 360 degrees, is 180 degrees. So pi radians is the same as 180 degrees. Well, 1/4 of a revolution, remember, a full revolution is 2 pi. So 1/4 of a revolution would be a full revolution divided by 4. Well, that's 2 pi divided by 4. Well, 2 pi divided by 4 we'll write as pi over 2 radians. Well, there's several ways to think of this. 1/4 of a revolution is 1/2 of 1/2. And 1/2 of a revolution is 180 degrees, so 1/2 of that would be 90 degrees. But we could also say, well, what's 1/4 of 360 degrees? Well, 360 degrees divided by 4 is 90 degrees. So pi over 2 is equivalent to 90 degrees. Okay. Let's go a little further. What about 1/6 of a revolution? 1/6 of a revolution. Well, a full revolution is 2 pi, and 1/6 of that would divide by 2, and 2 over 6 is 1/3, so this is the same thing as pi over 3 radians. Well, remember, a full revolution is also 360 degrees. What's 1/6 of 360 degrees? Oh, that's 60 degrees. So pi over 3 radians is the same thing as 60 degrees. Well, let's see about this. What about 1/8 of a revolution? One-eighth of a revolution then would be a full revolution, which is 2 pi divided by 8. And of course you can see 2 over 8 is 1/4. So this is the same thing as pi over 4 radians. Well, in terms of degrees, this is a little more work for us to do, but 1/8 is a half of 1/4, isn't it? If we look above, 1/8 is a half of 1/4. And half of a 1/4 revolution, which is 90 degrees, half of that is 45 degrees. But we could also say, how many times does 8 go under 360 degrees? And it goes 45 times. That's all I really did there, is I took 360 and divided by 8, and I got 45. And that's the way I could have done that. Okay, let's see what else we might do. How about 1/12 of a revolution? Well, 1/12 of a revolution will be a full revolution, which is 2 pi divided by a 12. And 2 over 12 is 1 over 6, isn't it? So we would write this as pi over 6 radians. Now, of course, 1/12 of a revolution is the same as 1/12 of 360 degrees. And 1/12 of 360 degrees is 30 degrees. Well, the angles that I've written here are very, very critical in knowing the relationship between radians and degrees. These angles that you see here, 30 degrees, 45 degrees, 60 degrees, 90 degrees, are critical for us to go through the rest of the course. We've got to understand that. Now, let me write down another set of diagrams here, just so that we'll see something to refer to later on. And you know, maybe I'll wait for that. Let's go directly to. Let me make a note before I go forward. When we see an angle, okay, when we see an angle and no units are observed, then no units of an angle measure are specified. Then radian measure is implied, okay? So if we see somewhere the angle theta is equal to pi, or we see somewhere that the angle theta is equal to 2, then we have to understand that that means, that means that theta is pi radians. If we don't see it at all, it means radians. So in this case, pi radians is half of a revolution, isn't it? Or the equivalent of 180 degrees. Or in the case we see that theta is equal to 2, then if we don't have the degree sign there and nothing else, then we assume that that means 2 radians. Now, 2 radians is not so easy for us to know. Remember, I told you previously that a radian is approximately 57 degrees. So 2 radians would be what? Approximately 114 degrees, approximately. So just keep that in mind. If you don't see any degrees, then you know that we're talking about radian measure. On the next page, what I want to do is introduce the concept of converting between degree measure and radian measure. So what we want to do is be able to take degrees and convert to radians, and take radians and convert to degrees. And so what we need are some conversion factors Of course, you study these kinds of things in science a lot. What we know already is that 360 degrees is equivalent to 2 pi radians. Okay, we already know that. And of course, from that, we concluded that 180 degrees is the same as pi radians. That's what we actually used. So we can conclude from that information what is 1 degree measured in radians. So 180 degrees is pi radians. So 1 degree, well, we'd take 180 degrees and divide by 180 to get 1 degree, wouldn't we? So that would mean we would take pi and divide by 180 to find out what 1 degree is. So 1 degree is pi over 180 radians. Okay? And on the other hand, what is 1 radian? Well, 1 radian, I said, was about 57 degrees, but let's look at it this way. If pi radians, if pi radians is 180 degrees, then if I take pi radians and divide by pi, that's 1 radian. And if I divide the right side by pi, I need to divide the left side by pi. So 1 radian is pi over 180 over pi degrees. And so these give us our conversion factors. Let me write it this way. 1, to convert degrees to radians. To convert from degrees to radians, use the conversion factor by multiplying degrees by pi radians over 180 degrees. On the other hand, and I'll show you how to remember this when we get ready to do it. On the other hand, to convert from radians to degrees, we use the other conversion factor, which is 180 divided by pi. What we'll do is we'll multiply, say we're given radians, so we'll multiply our radians by the conversion factor that is 180 degrees divided by pi radians. The idea here is 180 degrees and pi radians are the same, so 180 degrees divided by pi radians is 1, isn't it? And so when we multiply 1, we're not changing anything. On number 1, in the case of pi radians over 180 degrees, since those are the same, that's just a 1. And so when we multiply degrees by a 1, we don't change anything, but we're going to convert it to radians. Okay. So let's look at several applications of doing this. And here, let's first convert 135 degrees. Okay. Well, this is going to be in the measure of converting degrees. Convert degrees. Okay, so we're given 135 degrees and we're asked to convert it to radians. So that I can see that this comes out in the way that I want to do it, I'm going to write this way. I'm going to say, okay, take this 135 degrees, and let me write it in this fashion for what I'm going to do next. Now, I need to multiply by a conversion factor, and I've got 2 different ones, and I can't remember which one I use. Well, here's the way I remember which one to use, is that we need degrees to cancel and be replaced with radians, don't we? So that means what we need is a conversion factor that has degrees on bottom. Well, the one that has degrees on bottom is when there's 180 down here, isn't there? 180 degrees. And so that means on top is our pi radians. So this conversion factor then is going to give us put us in a position where the degrees are going to cancel, and we're going to be left with the units radian, the radian units. So when we do this multiplication, notice we'll get 135 times pi divided by 180 radians, and then we reduce that fraction. Would have to decide, let's see, I think 45 goes into both of those, and I'm convinced that you can finish this out, that 45 goes into 135 3 times, and 45 goes into 180 4 times. So this is 3 pi over 4 radians. So 135 degrees is 3 pi over 4 radians. Okay, next let's convert 540 degrees to radians. Well, we're going to do the kind of the same thing. I'm going to think, well, that's 540, let's think degrees this way. Now, what I need is a conversion factor that has degrees on bottom, so they'll cancel, and radians on top. But that's got to be a 1. And since I know that pi radians is the same as 180 degrees, then I'm multiplying by a 1. And I'm fortunate then that my degrees cancel. Now, I've got to do a little bit of work here, because what I'm going to get, of course, is 540 pi divided by 180 radians. And so I've got to see how to simplify that fraction. And what happens is 180 actually goes into 540 evenly 3 times. So this is a 3 pi radians. Okay, let's convert negative 270 degrees. Well, now we're going to have a negative 270 degrees, but we don't change anything except that we don't change anything of what we've done. We need degrees to cancel, so we need degrees down here. We need radians to be appearing, so we need radians up here. Oh, that's pi radians divided by 180 degrees, which is 1. So our degrees cancel, we're left with radians. This time we have a negative 270 pi over 180. And 90 goes into 273 times and into 182 times. And so this is negative 3 pi over 2 radians. Now, we're not always so fortunate, you know, that once in a while we have a situation where things don't divide evenly, like maybe what happened here. I mean, it hasn't happened so far. So let's convert, for instance, 61 degrees into radians. So we've got a 61 degrees. We need to do a conversion. So we've got to multiply by a conversion factor where the degrees will cancel. So we've got to have degrees on bottom and radians on top, don't we? And so once again, it's going to be pi radians over 180 degrees. And so that gives us 61 pi over 180 radians, okay? But 61 over 180 doesn't simplify nicely. It doesn't simplify in a whole way. And so in this case, what we will end up doing is that it's a little bit more than 1, isn't it? And so we'll go ahead and, well, I'm sorry, I'm not making much sense of this. What we'll do is approximate pi here. Since it doesn't come out evenly, and we won't get a whole number or a fractional number of pi that simplifies nicely, then we'll actually do the calculation. Get our calculator out, say 61 times pi divided by 180, and in that case, we're approximating it because we approximated pi for one thing. We get 1.06, I believe. Let me get my calculator out and double check this. Yes, we get 1.06 radians. And that makes a little bit of sense, since I had told you previously that 1 radian is about 57 degrees. And so 61 degrees would be a little bit more than 1 radian, and we see that it is. It's 1.06 radians approximately. Okay. Let's now convert the other direction. Given radians, let's calculate instead the degree measure. Okay, so we're going to convert radians. Of course, 2 degrees. Convert radians. And so let's suppose we're given negative pi over 2 radians. Now see, usually I wouldn't even put anything there, but in terms of the units, but I'll say negative pi over 2 radians. Now, okay, to convert that, what we're going to need to do is to multiply that negative pi over 2 radians in a way by a 1 that's in fractional form, but this time we need radians to cancel. So we need radians on bottom, and of course we need degrees to appear, so we need degrees on top. And so what relationship do we have where degrees and radians are the same? Well, we do know that 180 degrees is the same as pi radians. And so once we use that idea, of course, the radians will cancel, and we'll end up with only degrees. And notice here that the pi's will cancel as well. And so what we're going to have is a negative 180 over 2 degrees. And of course, 180 over 2 just simplifies to 90, so this is negative 90 degrees. Okay, let's convert, let's convert 9 pi over 2. Okay. Oh, let's do this. Let's convert 5 pi over 6 radians. 5 pi over 6 radians. Okay, so what we're going to do is we're going to take the 5 pi over 6 radians, and we're going to multiply it by an appropriate conversion factor, conversion fraction. Need radians here, degrees here. And so, of course, 180 degrees is the same as pi radians. So we'll have this opportunity now. We get the radians to cancel. Oh, and we also get the pi's to cancel. And so what we have is 5 times 180 over 6 degrees. And I'm looking at that, I see that 6 goes into 180 30 times, doesn't it? And so that's really 5 times 30, or 150 degrees. So 5 pi over 6 radians is the same as 150 degrees. Let's see, how about we convert something like 2 radians? 2 radians. Okay, well now here we go. We're going to take that 2 radians and multiply it by a conversion factor, which is a special form of 1. We need the radians to cancel. Okay, we need degrees to appear. So we've already been through this a couple of times, haven't we? So in this case, we're going to end up having the radians cancel, but no pi's to cancel with the 2 radians. And so we'll have 2 times 180, which is 360 divided by pi degrees. Now, what we'll do is get out our calculator, okay? And we'll approximate that because it doesn't come out evenly. So we'll approximate that. And when we do, we'll get, and I'm going to approximate it to 100ths, 2 decimal places. So you get 114.59 degrees. And just relating back to what we've already said a couple of times, that 1 radian is approximately 57 degrees. So you can imagine here that it makes sense that 2 radians is approximately 114 degrees, but we've given a little better approximation for it by going through this conversion. Okay, well, I think from this we ought to be able to do any of these conversions we want. So now we're going to continue on the next page with some other ideas about radians and degrees and angles and their measure, a few more concepts.